The insane engineering of SpaceX Raptor Engines. Elon Musk, the CEO of SpaceX, is dead intent on going to Mars. To accomplish so, a massive new spacecraft fueled by an entirely new rocket engine will be needed, unlike anything ever seen before. Step Forward Raptor, the future of SpaceX's endeavors. In this video, we'll walk you through the insane engineering of SpaceX Raptor Engines. All this hype around the engine makes us all wonder what ingenious piece of engineering makes this engine far more superior to any other rocket engine in the entire industry, and how it'll revolutionize space travel for years to come. Well, stick around as we discuss the wild physics of Elon Musk's methane-guzzling super rocket. So let's begin the video. Raptor is designed to power the new reusable vehicles SpaceX is building, the Starship spacecraft and the Super Heavy rocket. Combined, these vast machines are designed to take up to 100 people into space, possibly to the Moon and Mars, with a tentative launch of humans around the Moon planned in 2023. SpaceX tested the first flight-ready version of Raptor in February 2019, and last week it flew a Raptor for the first time on a hop test of a prototype of Starship called Starhopper. The engine's been in development for the better part of a decade, going through several iterations. At its core, it's like other engines, burning chemical fuel to produce thrust. But its use of liquid oxygen and methane, something largely unprecedented in the rocket industry, and its innovative design means that it just might be SpaceX's ace in the hole when it comes to exploring the solar system. There is no other rocket engine capable of producing as much energy out of liquid methane and liquid oxygen as the Raptor engine, and making it reusable with little to no refurbishment is the idea. Reusability is a key aspect. As Musk has said, each engine needs to be capable of flying up to 1,000 times to support the ambitious operations of Starship. That's a major challenge. The most reused engines in space exploration history were the main engines on each space shuttle, which flew up to only a few dozen times each. SpaceX's existing engine is called Merlin, which is used on its operational Falcon 9 and Falcon Heavy rockets, but Raptor heralds a significant improvement. One is that it has double the thrust of its predecessor thanks to a much higher pressure, 380,000 pounds of thrust at sea level versus 190,000 pounds, despite being a similar size. The other is the use of methane. No methane-powered rocket has ever made it to orbit, with Starhopper's test hop the other day being the first time a methane-powered rocket engine had taken flight. Methane prevents a buildup of deposits in the engine compared to other fuels like kerosene, a process known as coking, while its higher performance allows for lower costs. Raptor also uses what's known as a full-flow stage combustion engine, only the third engine in history to employ this technique, whereas Merlin uses the more common open-cycle system. The previous two attempts at such an engine, one in the Soviet Union in the 1960s and another in the US in the early 2000s, never made it beyond testing. A full-flow stage combustion engine refers to how a pump spins a turbine to drive the engine, using what's called a pre-burner to get this process going by injecting a small amount of fuel. Normally, some of the propellant is expended in a traditional open-cycle engine to start this process, but Raptor will use every drop of propellant available, making it one of the most efficient rocket engines ever built. Raptor burns that fuel at a high enough pressure that can then steer the fire from pre-burner back into the combustion chamber and completely burn that propellant with the rest of the propellants. And it does this in a very clever way that only the Russians have done previously, by putting all the propellant in the engine through the pre-burners. The result is that the Raptor has a much higher pressure than Merlin, about 3 times greater, making it the highest pressure rocket engine in existence and leading to its aforementioned larger thrust than Merlin despite its smaller size. In 2016, Musk referred to the insane pressure inside the main chamber of the engine, 300 bars, which needed the development of a new metal alloy. Of course, Raptor's other major innovation over its predecessor is the use of methane, which harkens back to SpaceX's ultimate goal. SpaceX isn't the only company moving to methane, as rival firm Blue Origin, headed by Amazon CEO Jeff Bezos, is also developing its own methane engine, called the Blue Engine 4. With numerous benefits, it's a switch that almost seems long overdue. Most previous rocket engines have relied on using fossil fuels like kerosene in place of methane. But the main benefit of using methane is that it has a higher performance than other fuels, meaning the rocket can be smaller. Its lower cost too means the total cost of launching can be brought way down. This could be crucial because the number of Raptor engines SpaceX is looking to build is immense, to say the least. Each Starship vehicle is designed to fly with 6 Raptor engines, along with 35 on the Super Heavy rocket, a total of 41 per launch. SpaceX's biggest rocket so far, the Falcon Heavy, launches with 28 Merlin engines. With the number of launches SpaceX is planning for Starship and Super Heavy, their rate of production will need to increase significantly. Elon's talked about making one in 12 hours, which would be unheard of in the industry. Even if they made one a week, that's pretty impressive. It's also believed that methane could be available on the surface of Mars or elsewhere in space to be used as fuel, perhaps by mining water and carbon dioxide, known as in situ resource utilization. You could reasonably easily extract methane from the Martian surface and potentially the lunar surface. This is vital to SpaceX's goal of regular trips to and from Mars with Starship, allowing it to be almost self-sufficient in terms of fuel. This has been the holy grail of solar system access for humanity, because when you can refuel in space, now all of a sudden your propellant doesn't have to come from Earth. So are you guys enjoying the video? In theory, the Raptor engine works perfectly, but is production going as smoothly as well? We have the answer, but can you guess it? So while you think, do subscribe to our channel and click on the bell icon to receive instant notification about all our future videos. Even though the Raptor is a remarkable feat of engineering, producing it on a commercial scale is an entirely separate issue, one that Elon Musk and SpaceX are struggling with right now. Elon Musk is angry with the lack of progress SpaceX has made in developing the Raptor engines that power its Starship rocket. He described a dire situation the day after Thanksgiving in a company-wide email. "The Raptor production crisis is much worse than it seemed a few weeks ago," Musk wrote. "We face genuine risk of bankruptcy if we cannot achieve a Starship flight rate of at least one every 2 weeks next year," Musk added later. Musk's email to SpaceX employees provides more context to the significance of the departure of former Vice President of Propulsion, Will Helsley, earlier this month. Helsley had been taken off Raptor development before he left, with Musk noting in his email that the company's leadership has been digging into the program's problems since then, and discovering the circumstances to be far more severe than Musk previously thought. The billionaire founder has repeatedly described the production as the most difficult part of creating SpaceX's mammoth rocket. The company has steadily built up its Starship production and testing facility in Boca Chica, Texas, with multiple prototypes in work simultaneously. Alongside these lofty claims, Raptor represents a large shift in SpaceX's ambitions from modest Earth-based launches to potentially exploration of the solar system. Starhopper's recent test was a key step in the right direction, and if Raptor even partially lives up to some of its promises, the future could be very bright indeed. If SpaceX really does reach Mars, Raptor will have a huge part to play. Well, do you think Musk has bitten off more than he can chew? Or will his company be able to deliver on their promise of delivering the powerful and efficient rocket engine on time? Let us know in the comments below. And if you want to watch more of our amazing videos, then stay tuned.